Good afternoon to my dear children. The last one unit is over, that is unit 1 is completely over. I hope that you maybe learned the one-word question, everything one-word question. Today we are going to learn about the second unit, that is quantum mechanical model of atom. The small class we are learn about the model of an atom, that is Bohr atom model, J.J. Thomson, etc. The models we are learn. Here also the same concept we are learning with some derivation. We are learning some derivation, including some derivation we are going to learn. Today learning objectives to learn about the wave particle duality of matter. What is our learning objective? To learn about the wave particle duality of matter. This is our today learning objectives. Before that, we can just discuss about the introduction of an atom model. Okay, introduction about the atom model. All things are made up of matter. Am I right? All things are made up of matter. Atom is considered as a non-divisible until the discovery of subatomic particles. Which are subatomic particles? Electron, proton and neutron. Am I right? According to J.J. Thomson, cathode ray experiment shows that an atom consists of negatively charged sphere in which electrons are revolved, in which electrons are embedded like a seeds of watermelon. The next experiment is Rutherford bombarded a thin cold foil with a stream of alpha particles. Okay, Rutherford bombarded a thin cold foil with a stream of moving alpha particles. He get a 3 observation. What are the 3 observation he get by the experiment? Let us discuss by means of diagram. Okay, first you draw the diagram. Here they are taking a thin foil of coal, Here the alpha particles are passed through the foil. Alpha particles are passed through the foil. This is the thin cold foil. Here, what is the observation? First one is most of the alpha particles are passed through the foil. Most of the alpha particles are passed through the foil. Clear? What is the first one? Most of the alpha particles are passed through the foil. This is the first point. Okay. The second one is some of them were deflected through a small angle. Some of them are deflected. Some of them are deflected through a small angle. Okay. Some of them are deflected. Some of them are reflected through a small angle here. The third, very few of the alpha particles very few, a small, very few of the alpha particles, okay, deflected, that is reflected back by 180 degree, back by 180 degree, okay. Very few of the alpha particles were reflected back, okay, reflected back with comma by 180 degree. Clear? What is the first point? It's a very, very important point. Very, very important. The 3 points. What is the Rutherford observation? During the bombardment of thin cold foil. What are the observations? First one is, what is the first one? First one is most of the alpha particles passed through the foil. Can you learn? Second one, some of them were deflected through a small angle. Very few of alpha particles reflected back by 180 degree. Back by how much degree? 180 degree. Okay, it's a very, very important question. Few of them reflected back 180 degree. Okay, these are the 3 important observations get from Rutherford experiment. By means of Rutherford observation, he proposed that atoms, there is a tiny positively charged nucleus and the electrons are moving around the nucleus with high speed. Okay. Next about, we are learning one of the theory. What the theory means? Theory of electromagnetic radiation. Theory of electromagnetic radiation. What is the theory? State that moving charged particles should continuously lose its energy. One of the particles is moving, it is continuously moving, it loses its energy in the form of radiation. This is called what? The theory of electromagnetic radiation. This model does not explain the distribution of electrons around the nucleus and their energy. Clear? This model does not explain the distribution of electrons around the nucleus and their energy. The next is about Bohr atom model. Okay, Bohr atom model. What is about the Bohr atom model? The electrons are revolving around the nucleus in a circular path called orbit. Okay, circular path. The electrons are revolving around the nucleus in a circular path called what? Orbit. That we are saying shell, K shell, L shell, M shell, N shell, etc. The second one, the electrons are revolving around the nucleus in a circular path. Here the angular momentum of an electron must be equal to integral multiple of h by 2 pi. Whenever the electrons are revolving around the nucleus in a circular path, here the angular momentum, what is the angular momentum? That is mvr. We are seeing the formula, the symbol we are giving, mvr. The angular momentum of the electron must be equal to integral multiple of h by 2 pi. That's the second point. The third is the very, very important point. When an electron jumps from higher energy level, that is we are saying E2, higher energy level, that we are saying E2, higher energy level to the lower energy level, that is E1. Okay? When an electron jumps from higher energy level to the lower energy level, otherwise higher energy state to lower energy state, its energy, the excess energy is emitted as radiation. The third point is very, very important. Okay, they have some excess energy. This energy, this excess energy emitted as radiation. Okay, they have a formula. What is the formula? The frequency of the emitted radiation is given by the formula. What is the formula? Is E2 minus E1 is equal to h into nu. E2, what is E2? It is a higher energy state. What is E1? It is a lower energy state. So the formula we can be written as E2 minus E1 is equal to H into nu. H, all of you know about that. That's the Planck's constant. Okay. Here we can be nu frequency. Nu is equal to E2 minus E1 divided by H. That is the formula. How can you calculate frequency nu? E2 minus E1 divided by H. Next, about the fourth point. This is also very important. When an electron jumps from lower energy to higher energy, when an electron jumps from lower energy to the higher energy, here the suitable energy is supplied to an electron. A suitable energy is supplied to an electron. Okay, these are the 4 points. I think that is a very easy point for the 3-mark question. Please, you should be learn this 3 point. Okay. Next up, what are the limitation of Bohr atomic model? What are the limitations? Okay, it is applicable to have only one electron, that is hydrogen, and also lithium, etc. Okay. And it is not applicable to multi-electron. It is not applicable to multi-electron atom. It is only, this concept is only applicable to there is a one electron atom, maybe hydrogen, lithium. These are the examples. Okay, but it is not applicable for the multi-electron atom. Okay, and this Bohr atom model was not explained, but unable to explain the splitting of spectral line in the presence of magnetic field or an electric field. What is about the magnetic field? That we are saying Zeeman effect. What is about the electric field? We are saying Stark effect. Am I right? Okay. It was unable to explain the splitting of spectral line in the presence of magnetic or electric field. These 2 points are the limitation of Bohr atomic model. Okay. Next we are learning about that. What is about the wave particle duality of the matter? Wave particles. For this wave particle duality of the matter, we are taking Einstein equation. We are using an Einstein equation. All of you know that one. Einstein. What is it about the Einstein equation? In the small class we may learn about the Einstein equation. What is that one? E is equal to mc square. Am I right? And also Planck's quantum theory. Also we learned that E is equal to h nu. Let us we can be write the expression. This is one of the very important question. It is a very important because the 3-mark question. Let us we can be discussed. Please all of you take the note and write. Okay. The wave particle of duality of the matter. It's a very important question. Please take the note. The wave particle duality of matter. The wave particle duality of matter. Here Albert Einstein proposed that light has dual nature. Okay. Here dual nature means it may have particle character and also may have wave character. That is called a dual nature. Okay. Here first equation we are taking. What is the first equation we are taking is Planck's according to the Planck's quantum theory. Planck's quantum theory. Okay, Planck's quantum theory. What's the first equation? E is equal to h nu. Can you write? E is equal to h nu. It is called first equation. Okay, h means Planck's constant. Nu is the frequency. We are saying nu. Okay. Second one. Einstein mass energy relationship. Einstein mass, energy, relationship. That is Einstein equation. According to Einstein equation, E is equal to mc square. Okay, E is equal to what? mc square. M means mass, C means velocity of the light. All of us know that one. M means what? Mass. Here we are taking equation number 2. Equation number 2. And comparing the both two equations, we are comparing equation 1 and 2. And comparing equation 1 and 2, E is equal to h nu and E is equal to mc square can be written as h nu is equal to mc square. H nu is equal to mc square. H nu is equal to mc square. Here, nu is equal to, here, first of all we learn about nu. Nu is equal to c by lambda. What is about the nu? Nu is equal to c by lambda. So, we are substituting the nu frequency nu to the above equation. So, what will you get? H into c by lambda is equal to mc square. Can you write? The value of nu is going to have what? C by lambda. C by lambda is what? Nu. So h into nu is equal to, that is nu is equal to what? C by lambda. C by lambda is equal to mc square. Here we are taking lambda. Lambda is equal to lambda is equal to h into c divided by mc square. Okay, mc square. Here, have it out. They are cancelled. So what is the answer? Lambda is equal to h by mc. Lambda is equal to what? Lambda is equal to h by mc. Okay, here lambda, as you know that one wavelength, h Planck's constant and m is the mass and c is the velocity. Here the c velocity can be replaced by velocity v. Okay, the c can be replaced by velocity v. Okay, this can be written as the above equation can be written as lambda is equal to h by mv. That is mass into velocity. Here, mass into velocity. Okay, this is the third equation and this is the fourth equation. And about the particle of matter with the mass, okay, mass m and moving with the velocity v, the equation can be written as lambda is equal to h by mv. Okay, here what is mv means momentum of the particle, momentum. What is mv means? M into v means is equal to momentum. So we can written as lambda is equal to h by v. Okay, this is the equation for wave particle duality of a matter. Okay, wave particle duality of matter. Can you write? Have it out? No doubt. Next one. Here I have some solved problem having. Here one of the solved problem. Calculating de Broglie wavelength in the following two cases. You should be calculate the de Broglie wavelength. Wavelength is lambda. You should be calculate lambda. One is for iron ball and another one is for electron. Am I right? One is for iron ball and another one is an electron. So First you write the formula lambda iron ball is equal to h by mass into velocity. This is the formula. Okay, you should write the data. Whatever data is given, that is the Planck's constant h. H is equal to 6.626 into 10 raised to minus 34 kilogram meter square second inverse. Okay, this is the value of h, and about the value of m is equal to 6.626 into 6 kilogram. Then about velocity v is equal to 10 meter per second. These are the following data. This is the constant value. H is the constant value. Okay. Then lambda is equal to lambda for iron ball is equal to, you should write h value 6.626 into 10 raised to minus 34 kilogram meter square second inverse divided by, what's the value of m? 6.626 kilogram into, what's the value of v? 10 meter per second. Okay, now they can be cancelled. Which are the cancelling? Kilogram can be cancelled. M can be cancelled. Second inverse can be cancelled. And this term is converted to 1. So we get is equal to lambda is equal to 1 into, here the 10 having means 1 into 10 to the power, here I have 3 4 minus 3 5. This is the answer. Clear? And also having 1 after m, so m. Can you write the first one? Next about the electron. How can you calculate the electron? Lambda for electron. Lambda electron is also same formula, h by mv. Clear? H by mv. So what is about the value of h? Already I told you. Lambda is equal to, what is the value of h? 6.626 into 10 raised to minus 34 kilogram meter square inverse. Okay, divided by mass also we should learn that one, 9.11 into 10 raised to minus 31 kilogram. Okay, kilogram into velocity. With the velocity, how much value? 72.73 meter per second. Second step, we are going to calculate an electron moving at 72.73 meter per second. Already I told you about the formula. Lambda for electron is equal to h by mv. H is the Planck's constant and m is the mass of an electron. And also v is the velocity already given to the data. And the lambda is equal to h value 6.626 into 10 to the power minus 34 kilogram meter square and second inverse divided by, and about the mass of an electron. What is the mass of an electron? And 9.11 into 10 raised to minus 31 kilogram into, and the velocity 72.73 meter per second. Next about lambda is equal to 6.626 into 10 raised to minus 34 kilogram meter square second inverse divided by, when you are multiplying this term to this term, both the two terms we are going to multiply. Now we get answer 662.6, okay, into 10 raised to minus 31 kilogram meters per second. Now we are cancelling kilogram cancelling, meter square cancelling. So our value is equal to lambda is equal to 0.01 into 10 to the power minus 3 meter. Clear? This can be written as lambda is equal to 1 into 10 raised to 5 meter. This is the answer for electron. Okay? Those who are interested in doing this problem, next one, please all of you take the textbook. Take your textbook, page number 39. Quantization of angular momentum and a de Broglie concept. Angular momentum and de Broglie concept. This is the next subheading. According to de Broglie concept, the electrons revolving around the nucleus exhibit both particle and wave character. Here, as per the de Broglie concept, the electrons are revolving around the nucleus. Here having exhibit both particle and also wave character. They have both wave character and also have the particle character. Here we are going to learn about that Davidson-German experiment. Okay, because the electron behave as a particle character and also wave character. In order for the electron wave to exist in phase, the circumference of the orbit should be an integral multiple of the wavelength of the electron wave. That means circumference of the orbit is equal to, that is the formula, circumference of the orbit is equal to L lambda. This is the formula, L lambda. Here 2 pi r is equal to L lambda. This is the formula, L lambda. 2 pi r is equal to what? L lambda. Here 2 pi r is equal to N into h by mv, because lambda is equal to h by mv. We are applying this value. Apply this value. N into h by mv. Then on rearranging this equation, we are rearranging the equation, the above equation. We get mvr, that is mv into r. mv into r is equal to nh. Okay, nh by 2 pi. Okay, we are taking mv into r is equal to nh by 2 pi. Clear? Okay, this is what? An angular momentum. mvr equal as what? Angular momentum. This is called what? Angular Shall I write the angular momentum formula? What is about the angular momentum formula? Is equal to nh by 2 pi. nh by 2 pi. They have a diagram about the wave nature of electron allowed both orbits. Okay, wave nature of electron. Some of them are not allowed. One is unallowed. Okay, which are not allowed and which are allowed. Okay. That you book draw with the help of the textbook. Please take the page number 42 and write. Next about what is about the Davison and Germer experiment. This is also one of the important questions. Davison and Germer experiment. Here, when a beam of electrons is allowed to fall on the nickel crystal, when a beam of electrons is allowed to fall on the nickel crystal, the electrons are scattered in different directions. Am I right? The electrons are scattered in the different direction. We are observing in a photographic plate. One of a photographic plate we are observing. The allowed beam of electrons is fall on the nickel crystal, and the recorded diffraction pattern. What is the diffraction pattern? Here means we get some diffraction pattern like that. Okay. Some of the diffraction pattern. Some of the diffraction pattern we are obtaining. The resultant diffraction pattern is similar to the X-ray diffraction pattern. Okay? So, electron, as per the Davison and Germer experiment, electrons also having wave character and also having the particle character. Electrons also having what character? Wave character and also the particle character. The next question is very important for the 2-mark question. Heisenberg uncertainty principle. Heisenberg. One of the 2-mark question, very important question. Heisenberg uncertainty principle. Here means it is impossible to measure simultaneously both the position and velocity. Position and velocity. It is impossible to measure simultaneously both the position and velocity of a microscopic particle. Here, which particle? Not an ordinary particle, microscopic. It is impossible to measure simultaneously both the position and the velocity of a microscopic particle with accuracy or absolutely. Okay? And also having your textbook having one definition, that you learn that one. It is impossible to accurately determine both the position and the momentum. Both the position and the momentum of a microscopic particle simultaneously. Okay. Then you should be learn the definition. And also, what is the formula for this question is delta x into delta p is equal to or greater than delta x into delta p is equal to or greater than h by 4 pi. What is the formula? As per the Heisenberg uncertainty principle, it is impossible to measure simultaneously both the position and the velocity of a microscopic particle absolutely or accurately. And given the formula, what is the formula? Delta x into delta b is equal to or greater than h by 4 pi. Here, Delta x and delta p are the uncertainty, position and momentum respectively. Position, delta x is position and momentum. Delta p means momentum. H means Planck's constant, and also by value of phi, all of you know that one, 3.14. By using, you have one solved problem that also we can discuss later. Okay. Page number 39. Here the Bohr atom model. They have, I think that 3 or 4 points. And you also write 4 points. That is the equation number. The point is enough. That is the page number 39. First point, second point, third point, and about the fourth point. With that formula, nu is equal to E2 minus E1 divided by H. That much is enough. Sorry. And next point also. Right. When a suitable energy is supplied to an electron, it will jump from lower energy orbit to the higher energy orbit. That much. Next, page number 40. Wave particle duality of matter. That you write. Start with here. The first equation is enough. Planck's quantum hypothesis. Up to the next page. The equation number 2.9 up to. That is lambda is equal to h by mv. And also lambda should be right there. Lambda is equal to h by p. That is momentum. Mass and velocity, momentum. Lambda is equal to h by mv. That is equal to p. Okay, yeah. M into v is equal to p. That. Next about page number 42. Heisenberg uncertainty principle. 42, top of the page. I think that the fourth line. 42, top of the page, fourth line. It is impossible to accurately determine both the position and the momentum of a microscopic particle simultaneously. Up to that much. And the next one, the formula. Delta x into delta p is equal to or greater than h by 4 pi. Where delta x and delta p are the uncertainties in the determining the position and the momentum respectively. That much. What of the 3 mark question? And also page number 39. Page number 39. I think that the third, fourth line, fifth line. What is the theory of electromagnetic radiation? Theory of electromagnetic radiation state that a moving charged particle should continuously lose its energy in the form of radiation. That is one of the 2 mark question. Anyhow, tomorrow assignment, you should be right. Assignment. Assignment page number 40. 40. Wave particles. Duality of matter. Only the expansion is enough, only the derivation is enough. No need to write that paragraph, only the derivation. Okay. Up to the one that is Planck's quantum hypothesis to next page. Okay. And about the second one is page number 42. Heisenberg uncertainty principle. Heisenberg. Heisenberg uncertain principle. These are the two questions. These are the repeating board exam question. You should be right this assignment and also check the answer whether it is a correct or wrong. You should be check it with pencil and also get signature from your parents and send to me. Okay. Thank you also. Thank you. Have a nice day.